All right, good morning, class. Today what we're going to do is look at rational expressions. But we're going to start out with a real quick factoring the following quadratics in the Bell work. And factoring is always something that you're doing, but you do use that in rational expressions. So we have x squared minus 24x plus 144 in here. And again, if you think through this, that's your eyeglasses. Let me get my pencil up there. Eyeglasses, split the x's, and then factors of 144 that would give me a sum of negative 24. Since this is positive, the third term, and this one's negative, that means that they both are negative terms. It would be negative 12 and negative 12. Don't forget, though, with those being exactly the same, it can be written as x minus 12 squared. Okay? Factoring. The second one, difference of two perfect squares. X squared is a perfect square. It's an even number exponent. And 64 is a perfect square. 8 times 8. Or in this case, negative 8 times negative 8. So my eyeglasses, and split my x's. And it's going to be minus 8 plus 8, because there's no middle term there. When you FOIL that, you get your x squared plus 8x minus 8x for the outsides, insides, and they would cancel. It leaves you with 0 for the middle term. And then minus 8 times positive 8 gives you the negative 64. Can't simplify that. It's done. There it is. Number 3, eyeglasses. Split your t's. Factors of 16, sum of 8. On this one, though, it would be plus 4 plus 4. That also can be written as t plus 4 squared, like the top one. And finally, number 4, eyeglasses. Split your x's. Factors of 12, sum of 8. Factors of 12, sum of 8, 12 and 1, 6 and 2, 3 and 4. Yeah, we're going to go with that 6 and 2. They're both positive. And that can't be simplified any further, so there it is. All right. Slide down to the next slide. So what is a rational expression? Glad you asked. A rational expression is a fraction with polynomial in the top, or a polynomial expression upstairs, and a polynomial expression downstairs. If you look at the one we've got here, that's a polynomial expression, and so is that. But there's a bar between it, and so that we have this fraction. That's a rational expression. All right, now I'm going to get rid of those, and we'll go back to this. What would you do in this case if you're trying to write it in its simplest form? The very first thing you want to do is factor it. So let's do the top and the bottom, and I'm going to write them both as eyeglasses. On the top, we've got x squared plus 7x plus 10, and we want factors of 10, sum of 7. So we're going to go x's, factors of 10, that'd be 10 and 1, 5 and 2, 5 and 2, and sum of positive 7, so it's going to be plus 5 plus 2. Don't do anything. Go down to the bottom. Change color here. Let's go to lighter purple. And now we're looking for factors of negative 10, sum of negative 3. Split your x's. Factors of negative 10. Now remember, with a product of negative 10, one's positive, one's negative, and because the middle term is negative, the bigger factor of negative 10 is going to be negative. So this time it would be minus 5 plus 2. All right. And at that point, then you want to look at these restrictions. State any restrictions. And you're going to focus in on the bottom factors. We would use the zero product property in this. If I'm looking at those two factors, I would take x minus 5 and set it equal to 0, x plus 2, set that equal to 0, and solve. Well, that would give me x is 5. Okay? And that would give me x is negative 2. Right? The problem is if I insert a 5 in there, I would get a 0. And if I inserted a negative 2 in on this one, no matter what I did on the other one, putting negative 2 over here wouldn't change that, but over here that's going to make that a 0. 0 times anything is 0. So we're having problems with both 5 and negative 2. That makes them restrictions. So x cannot equal 5 or negative 2, because it would drive the denominator to 0. And anytime you divide by 0, it's undefined. So there is your restrictions, and notice I underlined or I circled restrictions in there. Now, let's go back up and we'll simplify. I'm going to change this back to, let's go to a navy. And I'm looking at this level right here, okay? And what you want is binomials that are upstairs and downstairs that would cancel each other out, leaving 1s in their place. Well, x plus 2 would leave a 1 and a 1. And x plus 5, there are no x plus 5s down here, nor are there any x minus 5s upstairs. So what we're left with then is an x plus 5 over an x minus 5. Now, I like to leave those in parentheses because somehow when they're in parentheses, we don't tend to do anything with them. Those binomials must exactly match a binomial in the downstairs or in the opposite place, upstairs or downstairs. They have to match to be able to cancel out to 1s. Since these don't match, that is as simplified as I can get it. This is my simplified form along with my restrictions. Okay? If you need to pause at any time, go ahead and pause, but I'm going to go ahead and move to the next slide. On the next slide, we are now looking at a rational expression that's a single term. But notice that it's got two variables and it's got a number part. So I'm going to suggest this. Write it out, 24x to the third. Notice I spaced it. Y squared, gave it a little bit of room. And then I'm going to do the same thing with the bottom, negative 6x squared y cubed. I'm going to draw vertical lines there. Kind of help my eyeballs. And I'm going to try to simplify this first one. So we want to look at 24 and negative 6. Well, if you're simplifying that, okay, then you would be looking at factors of 24, also factors of 6, which would leave you with a negative 1. Now, that's kind of hard to see. Let's go back to black. A negative 1 and a positive 4. Okay, 4 over negative 1. On the x to the third over x squared, now we're looking at these two guys. There are 3 x's here, 2 x's here. We're going to cancel out 2 of them and leave 1 x upstairs and a 1 downstairs. In the third one, there are 2 y's and 3 y's, 2 in each of them, so we'll cancel this guy and leave a 1. Not a y squared, but a 1. And on this one, we're going to cancel out 2 of the y's and leave y to the first, or just y. Now, let's group. So we have, this is canceled, 4x times 1, or 4x. On the bottom, we got negative 1 times y, or negative y. Now, we want to migrate that negative sign out front so that it looks like the negative's out front. It's going to be negative 4x over y. That's my simplified form. There are 2 of them. There's that one and there's that one. These 2 over here are 4x over y, not negative 4x. So this negative requires it to be a or b. But notice the restrictions. Oh, we forgot the restrictions. No, we just haven't done them yet. So as I look at the restrictions on this, again, you're looking in the denominator. Let's go back up here. There are 2 types of variables. There's x variables and y variables. Well, x can't go to 0 because it's a product. If x equals 0, then it would drive that whole thing to be 0, so x cannot equal 0. And also notice there's a y down there, and y can also not equal 0. So I guess we're going to have to choose B. There are my restrictions. Okay? So it's simplified form along with those restrictions. Moving along, problem number 2, slide 4. Multiplying. Well, multiplication is very much like what we just looked at. What we're going to do is, you notice this multiplication sign, you're going to put a bar straight across there and multiply across. But we're going to start with simplifying this or getting it in its factored form. So we'll go with eyeglasses and x minus 5. I'm going to go ahead and slide in a pair of parentheses as well because that's a binomial. Split your x's for the upstairs. Factors of -6, sum of, looks like a 1. Well, that would be +3 minus 2. Okay, times, or the bar is there. And notice on this side then, I've got a difference of two perfect squares. So we're going to list that as x, split the x's, and 5s, split the 5s, and then there's a plus and a minus. Okay, on the downstairs, a little more traditional, split your x's, factors of 3, sum of 4, that can only be +3 plus 1. Nice thing about factoring, it's only one possible factoring form. And right at this point, we're now going to do our restrictions. Before we go any further, because when you start eliminating like this, you can lose track of them. So if we continue with the line of thought we had, if I use this one, x cannot equal 5. Because if it equals 5, that drives this guy to 0. The next one, x cannot equal -3. So again, not equal to -3. And on the last one, x cannot equal -1. So there's 3 restrictions. Now we can drive our bar straight across. So let's go to a black. We'll go with a thicker line on this one. And we'll do a bar straight across. Now, anything that's above or below, because these were multiplied, that's what that times meant, okay? These were multiplied, so anything that's above or below with our restrictions already noted, we can cancel out. So I see there's an x minus 5 here and an x minus 5 there. They leave a 1 in their places. Ah, there's an x plus 3 and an x plus 3. They also leave 1s in their places. No x minus 2s downstairs or x plus 5s downstairs. No x plus 1s upstairs. So we have those two guys times 1, and this guy downstairs times 1. Our finished form will be x minus 2 times x plus 5 over x plus 1. Now please note, if you did your restrictions at this point, you would only have one restriction. Because you did it at the start, you've got 3 restrictions. X cannot equal 5, -3, or -1. You would have lost the 5 and the -3 if you'd have waited till the very end. So you got to find your restrictions before you totally simplify, or go back to the very beginning like we did on the single term. All right? That's a good start. We'll have a second one that will be available on this section 8.4. It'll be 8.4B. Thank you.